Howdy, it's Tubalcain again, and this is number 1 in a series that I'm starting called Old Technology. There'll be more if it is successful. But what I have here is a very old 3-jaw chuck, and here's the old patent drawings, and I'll go show you those closer here in a minute. But Robert Ackert out of northern Michigan sent me this box with this old chuck in it, and he went to a great deal of effort. He made a beautiful little box, a little crate, got the corners sanded, it was all screwed together. Now I've already removed the screws, I've had it out once, but he went to the expense and effort of this, and inside is this 3-jaw chuck, and it was patented in 1855. And you think about that, that's before the Civil War. But let me get it out of there, if I can. And it is not a scroll chuck. You know, all of our chucks, look at the extra wood in there and a thing to keep it from moving around. It's built so much different than our modern scroll chucks. And I'm going to take it apart here and show you what's inside of it. And actually it's a pretty neat chuck. You know, just think what the technology was like and what the machinery that they used in order to manufacture this way back then. And here's the trademark, if I can lift this up. If that comes into view here. The Horton, the E. Horton and Son Company, Windsor Locks, Connecticut. Horton is the trademark. Now, the only thing I see wrong with this, well, there's more than one thing that's wrong. This sure would be a knuckle buster on your lathe as this spun around if you weren't careful. But back then, you know, there was no OSHA, and it was every man for himself. No guards, no nothing. But the other thing I notice on this is that the jaws do not move back very far. So in other words, the entire range here is relatively small. I'll back it out in a second and show you that it does not accommodate very large work. Thank you, Bob, for sending this our way, and that many people around the country will get to see something like this that is probably just in the museums. But it will handle up to about 2-inch diameter work. That's as far out as the jaws will move. And the thread size on the back is about 2.5 inches. Approximately 2.5 inches. So that won't fit any of my machines, but maybe that was a common size back then. But look at how that's built. And if you look at the patent drawings now, there's the pieces. No scroll. And in the second page here, of course, are all the descriptions that were written up by the lawyers way before we knew what suing somebody was about, I suppose. Eli Horton of Windsor Locks, Connecticut. You can look up all these patents on Google Patents. It's pretty interesting, but Bob sent me the links and so on, and attachments showing me this. All right, let's get started taking this apart. You know, when you think about it, 1855 patent, that doesn't mean it was made in 1855, but it probably was made, you know, within 20 years of that time, but that's not for sure either. But, you know, they hadn't invented electricity yet, or they knew what electricity was, but they didn't have electric motors and a grid and all the things that we have now. So this would have been done either by water power or steam power. And the lighting in the plant would have been natural light. They probably had to work near skylights or windows, or use gas lights, I suppose. Well, Bob has had this apart already, so it's been cleaned and oiled, and it's real easy to get apart. They sure didn't have one of these when this was made. Now those 3 bolts will hold what we call the backing plate. And I suppose back then they even had different backing plates, I don't know for sure. But that's what it looks like inside. Now, for those of you that do not know what a scroll is, and a scroll chuck, I do have a video on taking apart and cleaning a 3-jaw chuck. I forgot what the title is, but you can see the scroll in there, or the way it is built in comparison to this. Take a look at how this operates before I take it any farther apart. And the jaws are numbered K1, K2, and K3. But as I turn this, you can see they're all moving at once. It's kind of tight. I'm glad that Bob cleaned this, because it's nice and clean in there, and I'm not getting my hands all black, but I am getting a little bit oily. Now let's take this outer ring off and see what's in there. Of course, we can tell by looking at this tube, but I'll take these 6 screws out. I've got these 6 screws out, and it was a little tight getting that off. I had to tap it with a brass hammer. But when I pull that off, you see that there's a gear. See if that comes out. It'll come out because it shows it as a separate piece in that drawing. But what you're seeing here in some ways looks like a modern chuck with these bevel gears here. And of course, as you turn these square nuts here, or square studs, you're turning the entire gear so that all 3 of the gears are turning and the screws coming in or out depending on which direction you're moving it. And this is a casting, as you can see. Pretty nice casting too when you consider the technology of the time. No pyrometers yet. But these old guys were pretty smart, even 100 years ago or more. Before the advent of high-speed steel too. So they're using carbon steel tools. Notice that this ring gear, I'm going to call it a ring gear, I'm not sure if that's the exact term, is free to spin. Nice tight fit too. They got some good tolerances. I would like to have seen the original blueprints, and I do mean blueprints, not white prints or CAD drawings. I got the ring gear out. Look at the machining marks on there from well over 100 years ago. That's a casting also. Now when you look at these individual parts, I'm turning this now without the ring gear, and notice that the jaw can move in and out, but only one of the jaws is moving. Let's see if I can get those jaws out of there. I think you can also see, I'll back this up as far as it goes, and you can see why the jaws only have a maximum about to the edge of the chuck. In order to get the jaws out now, I backed these 2 jaws up so that they're in a position here where they will not cause any interference. And now I'll back this screw, not back it, I'll go all the way forward. Notice that's a left-hand Acme screw. And then it will come out, left hand, and a gear, and I think the gear is probably pressed on there, but that's a pretty nice piece right there. However, it doesn't appear to be hardened, at least the screw end isn't hard. Little center hole in each end. And then the jaws come out. And I'm only going to take one out. But there's the jaws. Interesting, with no vice caps or jaw caps like we use now. awful lot of tolerances that had to be kept in order for things to fit without binding, but yet loose enough so they can move in and out. Again, this is cast iron, the backing plate. This is a cast iron. This piece is cast iron. And I'm not sure about this without filing it or something, but this might be a cast iron. Back then it was necessary to cast as much as possible because they did not have to machine all this material away. Probably only a small amount of material removed in the machining operations. Now, pretty nifty. And then vice versa, when I go to put it back together, put this in and then the screw, and I need to time them so they'll all come together at about the same time. Or not about the same time, exactly the same time. You know what kind of strikes me here is that, well, I'm going to put this back together because it's clean and there's still a little oil on it. That'll go in. And I always use a brass hammer and a brass drift. Now it's home. Almost. No, still not home. There's my brass drift, and then it spins. Lay that aside. But what I was going to say is that you can be darn sure that in use chips are going to get in here and cause binding and other problems. And I'm sure this was taken apart many times over the years because you get enough chips inside of a regular scroll chuck, let alone what you would get in here, and think of all the binding and wear that you would have, and the extra time that they had to take to take this apart and clean it. And back then, remember, these guys are working 10, 12 hours a day. They were long days, you can be sure of that, with few breaks. No Coke machine, no candy machine. From this side, I don't have this screw in there yet, but that's quite a good fit with really virtually no slop. None. How much this was used over the years, I don't know, but probably a lot because you see marks on it, you see damage on it. And they wouldn't have had a budget where they can say, oh, get rid of that. We'll get new ones. I had a very interesting experience. I just got back from Cody, Wyoming, and I went into that big gun museum there, or actually it's a big museum, a section of it is guns, but since it's all historical, they had one room set up as if it was a gun making shop, and most of the equipment came from Savage Arms, and they were quite old, and it was interesting to think of what went on in those shops and what kind of men built the millions of guns and operated those machines and toiled endless hours for what was probably, we would consider, a mere pittance. Now, in order to get that back together, got to get this out just the right distance, a little farther than that, lay that in place, bring the jaw up, and get it started. I've been using this old lathe wrench since I do not have a chuck key for that. In order to reassemble this and time it correctly, this happens to be an 1¼ inch hole here on this side. 1¼ inch stock, so I put that in there and brought, oh, I thought I did, brought all of the jaws up against it. Got to back them out a little bit, do it again. All the jaws against it without cocking it. Then I'm going to put the ring gear on here, which I think will work. rather than on here first, so that it will mesh with the 3 bevel gears. And I think those are called bevel gears. That's what I'm going to call them. Okay. That. Then I'm going to wipe everything clean and put this on. Now whenever I take something apart, I always mark it. I just used a magic marker there, but I also made some little punch marks. I'm surprised I didn't find punch marks on here from previous mechanics. That kind of threw me for a loop, or maybe I just didn't look hard enough. And it's going to go on like that. I have 3 screws in here that I use to kind of bring it down together to make sure that it would come together. Got a little bit farther to go, and I'm using a brass hammer. I always use brass or lead when you do something like this. And in go the screws. I'm going to measure this one before I put that one in, but I just found it interesting that these other 3 bolts here that hold the backing plate on, I thought, wonder what kind of threads those are. So just went over to the cabinet and I took a brand new 3/8/16 modern nut, and sure enough, goes right on. It's a standard thread. That's kind of neat. I thought maybe they would have some of their own special threads back then. Like on the Stanley tools, all of the Stanley planes had special threads that Stanley came up with. Maybe so you couldn't interchange parts with other companies, I don't know. But then I brought this together to make sure that all of the jaws came together, and I got equal gaps, so I have it timed correctly. I'll use the old Genesis to bring those down, and I'll do the final tightening with a regular screwdriver. Yeah, imagine chips getting in there. They'd find their way in there mighty fast, you can be sure of that. Before I put the final screw in, I thought, well, I'll check that too. And that's a standard 1/4-20 modern plated nut. Goes right on there. I don't know why this surprises me so much, but it really does. And I'll bring those all down with a screwdriver, snug them up nice, and I'm ready to put the backing plate on. I don't know why there's twice as many holes there as what we need. And you know what? Someone did mark this. There's a center punch mark right there. So we don't know if Bob did that 6 weeks ago or if that was done by a man that died of old age by 1890. I feel like an archaeologist when I'm doing something like this, but I just found right here the number 13 stamped on it. But part of it's missing, which means that it was machined off at some time or another to make a new backing plate that would fit on this. So either the old one was damaged or they needed this chuck to fit on a different machine. Now, my witness marks are magic marker, but there is the other witness mark that I found on here and a corresponding one that is on the outer edge of this piece. But I'm just putting it on by my marks. Right like that. Oh, he's going from the other side. And I'll do that off camera. Did you note that they don't use Allen head cap screws like we use now? These are just what I would call a Philister head screw, because Mr. Allen of the Allen Screw Company probably wasn't born yet. And maybe they couldn't make a hex hole yet in millions and billions of screws. Certainly no socket head set screws as we know them now. They were all little square headed, what they called grub screws, or at least in England they call them grub screws, which I kind of like that. Let's see if it works now with my Armstrong wrench. It's a little tight, as I remember, when we get near the closed position and when we go all the way open, and then it frees up rather nicely in between. And these are 7/16 square heads around here. Well, I hope you like this little venture into the past here with the Horton Chuck. And if you want to look that up on the internet, look up Horton and use the patent date of November 13th, 1855. All hand lettered. Look at that beautiful hand lettering that they did back then. When I took drafting years ago, you know, you spent the first week or so learning lettering and how to do it neatly and in the style that the boss or the teacher required. Now that is never mentioned because it's all CAD generated. And that was kind of hard for me, especially when I took architectural drawing to develop that style. I never did master it for architectural, but now we don't waste our time on such things. But when you see somebody that still has that skill, and there's usually one old man in every drafting department that refused to convert to CAD, and he's still doing it the time-honored way. If you'd like to see more of this type, when opportunity arises and I find something old and of interest, leave a comment and I'll try to do more of these. Old technology. This is Tubalcain saying so long for now.